Hello and welcome back to the lab. As always, we are glad you are here, and we are very glad for the patrons that help keep the lights on. You guys help more than you know. I was looking around for some gear to put in front of the camera. Not that I need any more, the repair queue is quite long. But I've also been getting a lot of questions and comments about my Variac dim bulb isolation tester and some of the metering that I do in that unit. This was something I got specifically for the isolation supply in the lab. Just from taking a look at it, we get volts and we get watts, so that gives you an idea on the current. The neat thing about this guy is it does AC and DC. There's another meter that Simpson made. This is a Triplett. There's another one that does a very similar function to this. However, it does AC only. It doesn't do DC. I have been told that the accuracy on this meter is wanting and unspecified, at least in the service manual. I have not found a service manual for this yet, so we're kind of working on this one blind. But this meter does date, I believe, from 1956. So we're turning the Wayback Machine on a little bit. It does need an adapter because it is 2-wire plugs. And the only other control on the front of this is a high-low switch. That is for the high and low range on the watts setting. No, there's literally nothing. No battery doors, no nothing. This doesn't use any external power. This leather has seen much better days. So we'll work on that as well. But one of my goals is I'd like to put this in front of the Variac so I can just monitor what the isolation supply is doing. I have another meter that I will show in a future video. It does a great job, monitors all kinds of functions, but it's slow. So as I'm dialing up the Variac, I have to wait for it to update, adjust it some more, wait for it to update, adjust it some more. So I'm actually looking for something that might be less accurate, but faster, which is where I'm hoping this will fit the bill. But I do have a sneaking suspicion after taking a look at this. The feet are here, not here. That could cause some problems. For those that are new to needle meters, a lot of my audience is probably well-versed in them. However, we do have some people who are new to needle meters and non-digital and movement meters. There is a proper way to orient the test equipment on the bench. If you do not orient the test equipment the proper way, you will not get a proper reading. This meter will read differently if it's in this orientation versus this orientation, just from the way the meters are balanced. I was hoping when I ordered it that it was designed to be read like this because this is the way it was presented, but that seems to not be the case. So we'll have to go from there. All in all, line cord's in good shape, nice and pliable still, good and soft. This grommet has seen better days, so that's dried out. The switch is in good shape, good detent, not a problem. And what else do we got? Everything else seems to be okay. There's no cracks in the bakelite. This is a true bakelite case with a steel front and plastic meter panel. So we will buff this out and get this all cleaned up real nice. Hopefully I can pop the whole panel out and buff it, or we'll get up here. We do have some metal in the front. This feels like plastic. This feels like metal. But let's plug it in and see what's going on. I've got a meter that says it is 124 VRMS line voltage in the lab. So let's see what we have. Well, so it draws about 2.3 watts just to consume to drive the needle meter. And as we can see, the needle meter's up by the 100 and 50 volt setting, which is obviously wrong. I doubt, even with no specifications, being off by 25 volts shouldn't even be in the ballpark. But let's see what happens when we lay the meter down. I'm going to reposition the camera. Well, I think we found some of our accuracy already. I have not touched anything. It still says 124, and that's hitting really close. It's reading a bit high, but now it's only reading high by a couple of volts. When we use this in the isolation supply, we are going to have to use this on its back. But for right now, let's pop it open, take a look at what's inside. Okay, let's see what's going on here. Oh, well, that doesn't look healthy. Well, it's a very simple design. There's 2 resistors. These are wire wrap resistors, not coils. And we have a charcoal briquette. Gonna have to order some parts for this guy. We have a solder ball here. That was probably from manufacturer. And yeah, really 2 switches and a resistor, and that's about it. I do believe there is a... they don't use a current transformer in here, and that's why it works on DC. So I think it is just essentially RMS, because it treats the DC and the AC exactly the same. So, what kind of value resistors do we have? Let's see. URA. Almost dead short. 2 ohm. 0.3, 0.2. Oh, wow. Oh. Yeah, that's bad. That got hot. 4K. Wow. I don't think that's healthy anymore. Okay, so I am going to have to find a resistor. This was probably overstressed at some point where somebody had it in the low range and it just overheated. So I'm going to try to dig up some service documentation for this, see if I could figure out what these are supposed to be. There is writing on them. But yeah, I got to figure out what these resistors are so I can replace this one. These shouldn't be too hard to replace with modern equivalents. Oh, and we also had a casualty. The strap did go when I was moving this around. So, from a restoration standpoint, is once I find out what the values are, this will not take long. Very simple device, but hopefully it will fit the bill in the lab. Well, being able to check with DC definitely helped in this case. I have the, I'm actually pulling in 2 of the Keithley gear, the 2281S and the 2380, to check out the 2380 being a DC load, and the 2281S is my highest current power supply in the lab. It goes up to 6 amps. So I'm dumping 4.8 amps into the DC load through the watt meter, and the DC load is saying it's seeing 50.04 watts. So we are just shy of 50.04 watts. But the weird part is I have 12 volts coming out of the Keithley, and I've got 10.29 going into the load. So I'm losing about 2 volts, but I am getting the current through it. So that I'm starting to think that resistor might be part of the problem. But I don't know yet what that tells us on value. That could also be some voltage drop over the meter leads because my connections, especially for high current, were not great, to say the least. And I was running it through all meter lead cables, so having some voltage drop along the cables would not surprise me at all. As the mailman delivers, we have resistors. All right, so we're going to take these two resistors, replace them with this magic part number. These are 5.5 k ohm 1% resistors, so they are tighter tolerance than what was in there for sure. These are also 3 watt resistors, which given the wire size on these resistors, I'm sure were not 3 watts, so we should be good to go there. So let me get that done, and then I'll bring everybody back. I think that's the fastest wire up I've ever done. So I've got these big resistors got replaced with these two. This has been fixed before. When I looked at it, this has got to be very old damage because the hair thin wire, I don't know if you guys can actually see this. Kinda. But that wire was soldered to the terminal. So that hair thin wire was had been repaired. So this is long latent damage that we're fixing. But everything's all good to go. I'm going to find the Bakelite case wherever the lab decided to eat it, and then set it in. I do want to get some stainless hardware for this, so we are going to get some better screws, which will not be a problem. But I do need the box, and then we'll give this a test to make sure it reads correctly. Okay, let's get the unit plugged in. We should see activation over here, but nothing over here quite yet. We are reading... Actually, we are reading very well. We are reading right at 123. So we are... Let's see here. Let me get my heat gun. We'll plug that in. We'll do some wattage testing. Now, where I think I'm going to put this in my current limited and variac supply is after the dim bulbs and maybe even after the isolation transformer, just to kind of see what's coming out. Oh, nope, that's a polarized plug. It will need the adapter just because of polarized plug. Okay, so we're on the high range. That's way too hot. It was bouncing off the top end due to the fact that this unit decided to draw 1.3 kilowatts. Oops. So that's not going to work. Let's try my signal tracer. This should work. Draw a decent amount of current, but nothing crazy. We're on the low setting now. $28 watts. Reading about 20 watts, 24 watts. So, yeah, that's reading exactly like it's supposed to, but I need more current than that. My shaker table's got a heater in it, but it shouldn't be too big of a heater. So let's see what happens when we turn this on. Ah, there we go. So this is saying about 430 watts, 433 watts. We are right at the 400 watt line because I switched it over to high. High, let's check low. Just above the 400 watt line, we're at 433, so yeah, I'll take that. That's nice accuracy. So this is working quite well. I don't know how well this is going to work for the lighter loads, but for medium wattage loads, this will work very well. Well, since we have the ranges all done up, I'm going to pull this meter glass off, give this a nice polish, and replace some hardware. And then we'll be ready to put this in the Lab 110 supply. Well, you do not run into this every day, especially nowadays. I have the meter face out, and something happened when it was coming out. That is an actual glass meter face. So this is plate glass, so it was there must have been a weak point. The crack started over here. I don't know if that was over time or not, but as I was gently trying to move it out of the unit, it popped and shattered. So I will have to order up another piece of glass. Fortunately, I should be able to order some glass, if not get some glass cut to go back in. I just need the dimensions. This is just plate glass, so not even tempered. That's one of the reasons why it broke so easily. Oh, meter movements. Since I have the meter apart, this one actually comes apart from the back. You have to pull the 2 screws out on each side, and the meter comes out. The watt side of this meter has a wild movement. I don't know. Yeah, the camera will pick that up. It's got a coil inside of another coil to make a transformer to drive the movement of the meter. So that one's kind of on the crazy side. And actually, I have to fix this movement because if we take a look, where is it? Camera, there we are. This wing is down. This needs to bend up slightly. That's part of the meter zeroing mechanism. That should be good for mechanically zeroing the meter. If it's down too far, it can't actuate. So, all right. Well, now I need to put this in a very safe place while I work on getting another piece of plate glass for this. Fortunately, I think there's a stained glass place in town where I can go just get another piece of glass, and that won't be too much trouble. Well, with a small application of glass shaping tools, the broken is now the not broken. We have a much thicker piece of front glass for some strength. So I will see if this fits. If it does interfere with the meter movement, we'll obviously cut a thinner piece and go from there. But we have a nice piece of plate glass. Obviously, I have fingerprints all over this, so I will clean this before we put everything all back together. But let me get this in the meter, and we'll see how it goes. All right, meter's back together with a little bit shinier hardware. The meter goes together pretty easily. The critical thing to watch out for is the 0 adjustment screws, making sure they're centered in the V when the meter goes back together, because you don't want to bend one of the wings. That's what happened before, and I had to fix it earlier in the video. So we have new glass. Here's the old glass. Much thicker. Much more solid glass. Very much like that. We'll wipe off the fingerprints we just put on there. So next up is to get it put back in the case and get the new stainless hardware in. And then we ought to be really close to being finished with this one. And there we go. That looks a lot better than when we got started. Just zeroing out the meters. Looks good. So we'll plug this right into the Variac. So we're in on the Variac, and the Variac is booted up. My meter that I have hooked up in the isolation supply is nice. It's starting to have problems, so it will be a future restoration video. The display board's kind of going sideways on me. But it's nice, but it's slow. So I have to dial up the Variac, let it sit for a second, dial up the Variac, let it sit for a second. And the problem is when I get it close to or when I get it close to the top end of the variac, I need something that reacts a lot quicker. So this meter reacts as fast as I'm turning the knob. There's down, up, down. So that's going to help, because variacs, unless you get a special one, don't stop at 100%. They go over 100%. Now, the crazy part about that is everybody would think, oh, the meter's not calibrated. No, the variac matches. It says 149. So the variac's actually outputting 150 volts AC right now, which would way over-regulate. If I was tuning up a scope or something like that, it would overvolt the power supply. So as I'm cranking up the variac, I don't want to overshoot the device under test. So having something that responds a lot quicker, especially when I get close, because I can come up and I can continue to come up, and I can just dial in while my digital meter in the variac is still thinking about it, or my power analyzer hasn't even updated yet. I know I'm not way overshooting the device under test. So that is one of my main reasons why I wanted this particular unit. It'll be a permanent fixture in the variac. It'll just be off to the side of the desk, or off to the side of the bench, and while I'm bringing stuff in, I'll use this and a couple of other monitoring instruments to know what's going on. The chain of the power supply, I'm going to put this before the dim bulbs. So I'm going to have the variac, after the dim bulbs. So I'm going to have the variac, the variac, the dim bulb tester, this, and then my isolation transformer and supply power strips on the bench. So that way the dim bulbs can stay grounded, because they're on a metal chassis. There's metal everywhere. I want to keep the ground on that. And because right after this plug, I'm going directly to isolation transformer. So using this with a 2-wire plug isn't really going to matter too much, because I'm getting it to 2-wire after the isolation transformer anyway. We have high-low, and very conveniently, this tops out at 1,000 watts. My isolation transformer tops out at 1,000 watts as long as the power factor is 1. And so everything can go up to about 1,000 watts, which is good, because I do work on some heavy power stuff every once in a while. So finding a isolation transformer that could handle 1,000 watts was harder than I'd like to admit. But there we are. So thanks for stopping by and taking a look at this very vintage Triplett 660 meter. I'm going to get this integrated in the bench. If anybody has any suggestions or comments, please leave it in the comments section below. I do read all the comments. And if you're enjoying the content, hit the subscribe button and stick around. As always, more is always on the way, and I will see everybody in the next video.